Motion, Part 6. Uniform circular motion. In the previous video, we learned to represent the equations of motion by graphical method. In this video, we will learn about uniform circular motion. We have studied earlier that a body accelerates when there is a change in its velocity. There can be two reasons for the change in the velocity of an object. One is the change in the magnitude of the velocity, and the other is the change in the direction of velocity. Can you give an example when an object is changing only its direction of motion but not its magnitude of velocity? Now, let's take an example to understand it better. Have you ever run on a closed path, like around a playground? Let us consider the motion of an athlete on a closed path as our example. Look at this diagram of a rectangular field A, B, C, D. Suppose the athlete is running around in this rectangular track at a uniform speed in the straight parts of AB, BC, CD and DA. The athlete changes her direction of motion at the corners of the field to be in track. How many times will the athlete have to change her direction of motion while completing one round of the field? The athlete has to change her direction of motion 4 times in a rectangular track. Now, the athlete is running on a hexagonal path A, B, C, D, E, F. How many times do you think the athlete has to change her direction of motion? In an hexagonal path, the athlete has to change her direction of motion 6 times. Therefore, we can say that with the increase in the number of sides of the track, the athlete has to make more turns. If we increase the number of sides of the track indefinitely, then what do you think would happen to the shape of the track? On increasing the number of sides of the track indefinitely, the shape of the track will be that of a circle and the length of each of the sides will decrease to a point. Now, if the athlete moves along the circular path at a velocity of constant magnitude, then the change in her velocity is only due to the change in direction of motion. Therefore, we can say that the motion of an athlete on a circular path is an example of accelerated motion. Now, let's derive the speed of the athlete on a circular path. As we know, the circumference of a circular path with radius r can be calculated by the formula circumference is equal to 2 pi r. If the time taken by the athlete to complete one round in the circular path with radius r is t, then the speed of the athlete denoted by v is given by v is equal to 2 pi r upon t. Thus, the uniform circular motion is defined as the motion of an object around a circular path with uniform speed. Let us conduct a simple experiment to get a better understanding of the uniform circular motion. Take a piece of thread and tie a small stone at its one end. Then hold the other end of the thread and move the stone carefully in a circular path at constant speed. Now release the thread. Make sure not to hurt yourself or anyone else. Can you determine the direction of the stone after it was released? Repeat the experiment a few times by releasing the stone at different positions during the circular path and observe the direction of the stone after it is released. Did the direction of stone remain the same in all the cases or not? On careful observation, we can see that the stone moves along a straight line tangential to the circular path. This tangential motion of the stone occurs because the stone continues to move in the direction in which it was moving at the instant when it was released. It shows that when the stone is moving along a circular path, its direction of motion changes at every point. In this video, we learned about uniform circular motion.